In part 2 of our series on check continuations, we'll actually introduce check continuations when we wrap the delegate that we wrote last time in async. Once again, we return to our overly simple app, and that's the one where every time you tap the button, we see a new int between 1 and 50 wrapped in a circle. When the button is tapped, we make an async call to support. We call the next method, and the next method eventually returns an int. That's this piece. Then next calls the method ChooseNext on the delegate user. ChooseNext doesn't return a value. In our flow, that gets us here. Inside of the delegate user, ChooseNext calls didReturn on its delegate, which just happens to be support and supplies the number that it picked randomly. That gets us to here. And this is where we're stuck. We don't yet have a way of returning that number from next. We want to get the result all the way back to main view, so that button tap results in the same thing that we had last time when we made an asynchronous call to next and just got the value back. Right now, we're returning 0 every time. We've actually seen this problem before. The problem is the call to next, which includes the call to the delegate user's ChooseNext, happens up here, and the response happens down here. So how do we get that number that we get back in didReturn to somehow appear magically inside of next? In the past, we used async stream. And so we had this async stream, and we needed a way of placing number into that stream, and we used a continuation. This was an async stream continuation, and so we're able to use continuation.yield to place that number into the stream. And so we thought of this water slide as representing the async stream continuation. Now we could do that again, but there are 2 notes. First, we'd have to adjust main view to listen for ints in a stream instead of expecting to get just one value when it calls next. And second, an async stream continuation sends 0 or more elements. What we really want to enforce is that each time we call next, the result is just a single int. And for that, we need a different sort of continuation. As a metaphor this time, let's think of one of those automatic coffee makers where you add a pod and press a button. So step 1, we add a pod to the coffee maker. And when you do that, if there's already a pod inside the coffee maker, it expels it. It just assumes it's been used and it puts it in the trash or it somehow ejects it. So now the coffee maker has the pod inside. This is when we have what we might consider a check continuation. I don't have coffee yet, but I have a promise that I'm going to have coffee at some point in the future. Maybe much later, someone presses a button, and that's as if we've said continuation.resume, returning the coffee. And the coffee begins to brew, and I get the cup of coffee that is returned. Now, of course, like any metaphor, there are flaws in this one, but let's write the code and it's going to help point us in certain directions. Here's the next method as it currently stands. It's this asynchronous method that calls the delegate user's ChooseNext, and then it returns 0. Let's eliminate the return 0 because that's not really helpful to us. We actually want to return the real number back. And instead, we're going to return a check continuation using this method with check continuation. As you might guess, with check continuation is a commitment that I'm going to return something later. It's an asynchronous thing that I'm returning, and so we must await it. And as with async streams, we have to return the mechanism we use for returning that value, and that is our continuation. In this case, it's a check continuation. And now we can fulfill our commitment by calling resume on the continuation and providing the int that's going to be returned. In order to do that, I need to store my continuation somewhere so that I can access it from the other method. I'm creating it inside of next, but I have to resume from inside of didReturn. So we create a property called number continuation. It is of type check continuation, and you just can't create a check continuation. It's got to be a check continuation of something. This is a check continuation of ints that never fails. I make it optional so that it's initialized to nil, and then we can set it inside of our closure using the continuation that's provided. And so our number continuation equals the continuation that's provided. How is our continuation the right type? Well, it matches the signature of next, so it's a continuation of ints, and because next never throws, we know that this has no errors as well. And now inside of didReturn, we can fulfill our promise by resuming the number continuation. If the number continuation exists, we resume it, returning the number. And now the app works perfectly. We have completed our loop, and using continuations every time we tap the next button, the next method is called, the continuation is created, we then call choose next. Choose next calls back to did return, and that's where the continuation is resumed, and that completes the loop and sends the int back to main view. From the perspective of our app, even though we've written a lot of code inside of support, main view only sees a single async method next that it's calling. It doesn't know any of the complications that are happening behind the scenes. Now there's a caveat. A check continuation must return exactly once. And there are two possible problems with this. Problem one is, what happens if a check continuation returns more than once? In my coffee example, I think of this as I put in a new coffee pod and I press the brew button, and then I press it a second time without changing to a new pod. That's just nasty. That should be an error of some sort. And so in my did return, let's add a second resume. And so I'm resuming this twice. The first time I resume and return the number, the second time I resume and I return the number 5. If we run the app and tap the button, we'll get a fatal error. It is a Swift task continuation misuse. Specifically, we're told that next tried to resume its continuation more than once. We tried to brew 2 cups of coffee from the same pod. This is a fatal error at runtime. So a good habit to get into is to nil out the continuation after it resumes. And so here we resume the continuation, and in the very next line of code, we nil it out. That way we can't call it twice. So if a check continuation must return exactly once, the other type of problem is what happens if a check continuation doesn't return at all. In our coffee example, I think of this as I put in a pod and I never brew a cup of coffee with it. And then I put in another pod. And remember, when you put in the next pod, it discards the old one. So we're discarding the old pod without ever using it to brew coffee. That's just wasteful. So this case in did return, let's not resume the number continuation at all. Run the app, tap the button, and there's no problem. So tap the button again. This time we get a warning, it's not an error, that there's a Swift task continuation misuse, and this time it says next leaked its continuation. We threw out a coffee pod without ever brewing a cup from it. So why does this happen on the second button tap? The first time we tap the button, we get a new continuation in the closure, and we assign that new continuation to number continuation. Tap the button again, we create a new continuation, we assign that continuation to number continuation, and that means we're discarding the old value of number continuation without ever resuming it. That's our leak. Today's goal was to isolate the delegate pattern by wrapping it in an async call. So if you have legacy code or you're using a library where you can't change the delegate pattern, at least you can isolate it from the rest of your code using an async call. It doesn't require much extra work, and it's sort of boilerplatey. You'll get used to the way it looks. Now, much of our delegate code was already moved in the past to closure-based APIs. So next time, we'll look at wrapping closure-based APIs using async.